We're at that point in the course where we know a little bit about chemical formulas. We know what they mean, what they represent, how each atom is related to each other in terms of that a chemical formula, like say for example water, H2O, means 2 atoms of hydrogen and 1 atom of oxygen. But we want to get to the point where we know how to get those chemical formulas given a certain amount of information. So we're going to start with the simplest formula. So just as a background piece of information, we know about percent composition by mass, which tells us how the atoms are related in terms of the overall weight. We know how to find molar mass, for example. And percent composition by mass tells us how basically a mass ratio. That's not that helpful for us because our chemical formulas are about numbers. 2 atoms of hydrogen, 1 atom of oxygen. So simplest formula is going to be our starting point. And a simplest formula tells us the lowest mathematical ratio between atoms in a molecule. And while simplest formula, for example, like water, H2O, that is the actual chemical formula, some compounds have a formula that's not the simplest formula, it's something else. Like this one here, where if you were to, that is, I brought it up as glucose, 6 carbons, 12 hydrogens, 6 oxygens, that would mathematically reduce to CH2O. Now it's really important to understand that the simplest formula, that mathematical lowest ratio, is not necessarily the actual formula. It's also really important to understand that just because it might reduce to mathematically something else does not mean that the actual formula is in any way related to the simplest formula other than that mathematical relationship. So eventually we're going to get to the molecular formula, which I'm going to call the MF, and that is the actual chemical formula. Now we need to get simplest formula before we can get molecular formula, so that's going to be our starting point. And as I said, there's an example of an actual chemical formula. Okay, they are related mathematically, not necessarily chemically though. So if I take a list of some molecular formulas that actually exist, these are compounds that are real. In some cases, the simplest formula, the lowest ratio, is the same thing. In some cases, the lowest ratio is different. It's reduced. Now, what's kind of worthwhile to know, but we're not really going to make any use of it, is that for some of these things, the simplest formula could exist as its own thing, or as the same thing. In other cases, the simplest formula, rather, is just a mathematical lowest ratio, and that formula could not exist as an actual real compound. It's not really going to matter to us a whole lot which one is which, but it's worthwhile to know that it is a mathematical relationship and not necessarily an actual one. Okay, we now want to know how to find simplest formula. We're going to go through 4 steps. 3 steps all the time, a 4th step some of the time. So the first step is to use the percent composition numbers, which you will be given as masses. Second step is to turn those masses into moles. Third step is to divide all of those numbers of moles by the smallest number of moles. And that step seems a little bit weird at the time and is going to seem a little bit weird as you do it, but what it does is in most cases it turns it into whole number ratios because that's what our chemical formulas use. And then if it doesn't work that you get whole number ratios all the way around, and you're going to be really, really careful about rounding things off, then we can multiply by something because all of our chemical formulas do have whole number ratios. So we need to get those whole number ratios. And if they don't work out nearly perfectly at the end of step 3, then it should be fairly obvious and we'll have to do something from step 4. So let's take an example. You have a compound that has this percentage composition by mass. I like to set it up as a table so that things are nice and neat, but we're going to use the percent composition values as masses. So those numbers that were in the percent composition were listed as percent compositions, they go in as masses. So if I had 100 grams of that compound, I would have 46.88 grams of carbon, and so on. Then I'm going to calculate numbers of moles. Well, I calculate numbers of moles by dividing each element by the molar mass. So the mass of carbon gets divided by 12, and the mass of hydrogen gets divided by 1, and the mass of nitrogen gets divided by 14, the mass of oxygen gets divided by 16. That's going to give me a number of moles. It's not likely going to give me a nice whole number of moles, simply because 100 grams is probably not the molar mass. So then I use step 3. And step 3 is where I divide all of those numbers by the smallest number. So I look through and I end up with 1.56 moles of nitrogen and 1.56 moles of oxygen. You'll notice that I carried a couple of extra decimal places that I might not always need for other things. For this one, I want to carry some extra decimals, because if I round off a lot too much too early, then I'm going to ruin my answer. When I divide everything by 1.56, what I end up with is 2.5, 4, 1, and 1. Getting there. Almost at nice whole numbers. It's that 2.5 that's kind of ruining things right now. I cannot round that up to 3. I don't care what they told you in math class. Chemistry, you can't do that much rounding. So now what I'm going to do is step 4, where I multiply everything, in this case by 2, and that would give me 5, 8, 2, and 2. That is now whole number ratios of atoms, and my chemical formula then is made up of that ratio. So 5 carbons, 8 hydrogens, 2 nitrogens, 2 oxygens form a simplest formula. Is that the actual formula? I don't know. I need more information to find out, but I know that it is the correct simplest formula because it meets all the criteria. Now, in that table, there were a bunch of steps that we did and we have to do, but we don't necessarily need to write down what we did. So this simplified table would do the job just fine. I wouldn't need even the gaps, but to go from the mass to the number of moles to the divide by the smallest to the simplest formula would be just fine, even if I didn't have the divide by 12, divide by 14, divide by 1.54, whatever it was. Okay, so I can simplify the table a little bit, but there's key bits of information that should be in there. Now, I'm going to leave you with a few questions, these ones, and what I'm going to do is also show you what the answers are so you know if you're getting it right. If you're not getting some of them right, go back and make sure you're going through all the steps. There's 2 places that you can kind of go wrong. Number 1, forgetting steps. And often it's the step 2, right, where people start dividing by the smallest far too early. Second thing that can go wrong is too much rounding. And if you're rounding off too much, then you might not see that something is a 2.5. Or when you divide by the smallest, because you did so much rounding, everything doesn't look, nothing looks like a whole number. So don't round off too much or too early. Third thing that can sometimes go wrong is that when you're dividing things by the lowest, the one that you don't use the calculator for, that you just kind of do in your head, sometimes that one goes wrong, because it really, the number divided by itself should be a 1, but I've seen that one get mixed up far too often. Here are the answers for those questions. If you need them, just sort of double check what you're doing, and again, if you're getting different answers, please try again, double check that you're doing all the steps in that order. So at this point we can do simplest formulas. We can't do molecular formulas unless we have one more piece of information, but that's going to be the next thing that we do, and we'll talk to you then.